All right. Good to see you all. We are the Maps and Mixie Club. I am going to be facilitating our students and their talks. But first off, I'm going to hand it over to the professors at Delphi University to talk more about what this club's all about.
So today we are presenting a talk we've called Youth Driven Map Making with Open Data. Matt and Tracy and I will just briefly talk, and then Nicole will talk a little bit too about the context of this project, and then we'll just hand it over to our four high school student teams to discuss some of the work that they have been doing with map making and open data, and then we will have some time for Q&A at the end. So, just to begin with, this project is a project of the Maps at Mixie Club. I'll talk about what that is in a minute, but I just want to acknowledge that the Maps at Mixie Club is a project supported by the Mozilla Foundation's Responsible Computing Challenge, which is a partnership of the Omidyar Network, Mozilla Foundation, Schmidt Futures, Craig Newmark Philanthropies, and Mellon Foundation. I'm Suraj Chandani. Matt Karinga and Tracy Hogan are my co-faculty sponsors of the Maps at Mixie Club. Matt, do you want to?
Hey, everybody. Yeah, I'm Matt Karinga. So this project is a follow-up to a study that Suraj and I did of creating some new undergraduate computer science classes that integrated kind of politics and spatial justice into teaching computer science. And we were funded by Mozilla Foundation to create a more informal learning space. And we were interested in what types of projects people would bring to the club and what they wanted to learn and what they would pursue. So we created this open map club where pretty much anybody could come. And we've been running it since the fall and focusing on ideas of critical cartography, critical geography, spatial justice, and responsible computing. So we've been meeting about once a week in the fall. We've had different speakers come in. We've read some articles together. We've done software demos, GIS demos, and people brought in projects that they've been working on. Along with us, the faculty, Nicole has been coming. She's a grad student of ours who's a graduate student worker helping us out. And we've had local college students, people from the general public. And today, especially, we're going to highlight some of the high school students that we've been working with, especially ones at Midwood High School and Rachel Carson High School in Brooklyn. Tracy, do you just want to say hi? Tracy's our science educator. She's the third faculty member leading this group. So it's the three of us that have been working together in this project. And I'm going to turn it over to Nicole. She's going to MC the students as they talk about the project.
Thank you, Matt. My name is Nicole. I am a master's student for computer science education, specifically focusing on STEAM, makerspacey sort of things like interactive maps. We worked with the students both in person at the club meetings, especially in the fall. We had weekly meetings where we all came together and had thoughts about what sort of maps we wanted to make and helped each other with making those maps. In the spring, we switched to some more remote meetings where we talked to each other on Discord, we talked on Zoom, and we exchanged emails. We worked on developing good questions for research topics, like what makes a good research subject versus something that you might just be curious about. After that, we worked on finding which data sets would be best for everybody's presentations. Everybody had very interesting and different subjects that they wanted to research, so everybody had to have different data sets. But we also had to filter out those data sets because not everything that was in these massive data sets is useful for these research projects. All the students had to write code to make these interactive maps and visualize the data sets spatially. So we're here to present 4 interesting projects, and I'm going to pass it off to our first student, which is Zach.
Okay, hello, I'm Zach. I'm a junior at Midwood High School. And today I will be looking at the issue of unequal pool distribution across New York City and how it affects overall public health. So for my introduction, I am pretty much a lifelong swimmer. I've been swimming since I was 3 years old. And ever since I joined Midwood, I've always wanted to do research. Even before I joined Midwood, I was told about how I should probably join the research program because it'll be the most fun and it'll bring me the most intelligent projects that I could possibly do. And through a combination of swimming and research, I was able to make a project that I could truly enjoy doing and truly be excited about. And then through the use of data science, I was able to analyze public data and open data to find conclusions. So for my research questions, the first one is, how can NYC's open data help show which neighborhoods have less access to public pools? So this question will be answered with a map simply. You don't really need much data, and just showing off the data for this won't really make much sense. So a map will explain which areas lack pools and which don't. And then the second question of how might that relate to overall community health? So this is the part where I'm gonna have to bring in some statistics and a table and graph to really show the statistical significance. For my rationale, athletic infrastructure can heavily benefit health outcomes. So simply providing people with athletic infrastructure, such as pools, fields, and courts, can allow them to live healthier lifestyles regardless of other parts of their life. And pools are much rarer, but effectively, an area that has a pool most likely has enough funding or access to other athletic infrastructure. So we can use pools as a sort of benchmark for an area's access to infrastructure. And then we use this access correlated to health data and find our conclusions. So for my research backing, for quoting Jiang S., proximity and affordability of sports facilities were the strongest predictors of consistent physical activity among participants. So this ties back to what I was talking about, that simply providing people with the athletic infrastructure is probably going to make them more active in their own lifestyle, and this can tie back to a healthier life and better overall health. Then, according to Wang and et al., uneven spatial distribution of public sports facilities leads to significant disparities in residents' opportunities to engage in physical activity. So this is effectively what we're covering with the first research question, where we really ask, so what neighborhoods do have pools, what neighborhoods don't have pools, and how can this affect people? And then our third quote is, socioeconomic constraints remain one of the most persistent barriers to sports participation in urban communities, Goyaldi. And this ties back to maybe some future research that we can do later, where if we can possibly find a correlation between how rich an area is and their ability to have athletic infrastructure, this can then correlate over to health. And this can also show us why some areas lack athletic infrastructure and in turn have worse public health. So for our action plan and methodology, so first we have to organize public and private pools by community districts. So here we have two lists. We'll go one by one. So the list on the left, we made that one using code, using the overall data set for public pools. So for this, we used Open Data NYC. I used the pool inspection records. The pool inspection list is around 5,000 entries long. So firstly, we shortened that pool inspection list by simply removing all copies. This brought it down to around 2,000 entries. Then manually, I went and removed all copies that couldn't be removed with duplicate removal, such as when people misspell a name or add an extra period at the end. And at the end of the day, I ended up with a little over 1,000 pools across New York, public pools specifically. And on the right is the pool, which I also handmade without any code really. And what I did here was I simply went into the public pool registry, because there is one on Open Data NYC, and found the pools for every district. So this one is quite easier to make than the one on the left. Moving on, we had to build and find maps. So first we're going to talk about the building and the coding. So here's the first part of the code. And for the first file that we have to use is a file that contains coordinates of all the community districts and neighborhood tabulation areas of New York. So effectively, what is this going to do? When we combine this and spatially join it with the second file, which is the location of all the pools, what the program can do is read the locations of the pools and end up building a list telling us how many pools are in each specific district, which we can then use to make a map. So this uses a spatial join to get this data. Then this part of the code we use to make a map, simply talking about how large we want it to be, which columns we want it to use. Then this third part took a bit of time, but because the difference between the largest district and the smallest district was so large, we had to go in and manually switch some of the colors. For example, districts with no pools at all, I had to switch their color to gray so that it would be more obvious to the naked eye. Then districts with 35 pools, 70 pools, and 115 pools, since they were so large comparatively to other districts, where most districts averaged like maybe 10, maybe 20 pools at most, I also plotted these districts out in a specifically distinct color so that it would be easier to see. Moving on to the actual map, here it is. So let's talk about the significant values first, and then we're going to talk about the overall legend. Once again, count 1, that's areas with no pools at all. So they are these gray areas. So obviously you got Central Park here, doesn't have any pools. Then count equals 35. So pools with the 35, areas with 35 pools. There's a few of them. Then count 70, areas with an area with 70 pools, there's one of them. And then count 115, an area with 115 public pools. Once again, there's only one of them. So because you see most pools fall within this range, this slight yellow range between 2 and 8 pools, if I tried to make the legend go from 2 to 115, you really would not see the difference between the smaller ranges. So to make it more visible, we simply took these numbers out of the legend to make it more legible. So moving on to the finding and investigating, we had to use obesity rates in New York as our health indicator. This isn't the best thing that I could possibly have used because so much more goes into it, which you'll see when I actually try to do the statistical correlation. But while I was researching other health deficiencies and other ailments across New York, most of them were recorded by hospital, not district or area. So trying to find some data that talks about heart disease, for example, would be a lot harder, and I'll leave that for future research. Moving on to find the correlation. So we simply use the graph here to graph it. So this is the graph of relation of obesity to public pools. So the y-axis is the percentage of the of the population of each community district that is obese. For example, this community district has 0 pools and around 45% of its population is obese. And this district, for example, has around 15% obesity rate, but it has 5 public pools. But at the end of the day, as you see, there's not really much of a trend line and not really much correlation between the two. This is more visible on the next slide, whereas you see everything ends up clustered over here with very little correlation. Once again, 0.08, a bit more this time, but still not enough to make a final assumption from the data. And then finally, the relation of obesity to overall pools has about the same amount of relation as the previous slide, except there's a few differences. Future planning. So this is really important because, as you see, this didn't come out like most projects where we got our hypothesis proved, we got our hypothesis disproved. So we're going to have to do something in the future. So what do? Using other statistical correlation methods can be one way, but honestly, with such little correlation and such different values, I don't think this is going to help no matter what. We already calculated the R value. Can't really do much about this. Our second choice is to find other Y variables that can compare to this and have more reliability than a multifaceted issue such as obesity. I said obesity relies on a lot more food access, food quality, and there's so much more that goes into it than just availability of athletic infrastructure. So we might change that. As I said before, we might try finding something for heart disease, for example, which would be a bit more reliable than just obesity. Then after I do this and I can successfully find some amount of correlation, which is what I hope I can do. I think throughout the year, I want to extend my research nationwide, looking at it through the scope of states rather than just in New York to really get a good national scope of the picture. And then finally, I can find a way to include population in the statistical methods. I really didn't look at the population of the different districts. I had them listed down, but I couldn't find a way to include them. So that's another thing I can do in the future to make this more reliable of a presentation. So here are my citations, and thank you for tuning in and listening.
Thanks, Zach. Next, we're going to move on to Sasha's presentation.
Hey everybody, it's my presentation about New York City open data. And this project is about housing affordability dynamics in New York City and a census tract analysis of income, rent, and rent burden change since 2010 till 2022. My name is Sasha Borisova, and I am a senior research student in Rachel Carson High School. I'm a person who was very curious about real problems, and I was really excited to try to research a real research using aerial data, and open data really helped me to do that. That's why I combined Python code and open data to create maps that really helps visualize the gross median rent change in New York City since years 2010 till 2022. The research that I had was how have changes in income and rent between 2010 and 2022 affected housing affordability across New York City census tracts. since it's much easier to get data for census tracts, I decided to stay on them. And where has rent increased faster than income, leading to higher rent burdens? And when I was thinking about the question where, the maps came up in my mind very fast. My objective was to track how income changed across New York City from 2010 to 2022, to track how rent changed over this time as well, and see where rent went up faster than income. I also really wanted to look at the rent burden and how it's changed in different areas of New York City. As person who live in New York City and know a little bit about rent, I understand how hard it may be sometimes to pay the rent or find the affordable housing for myself. And it was more not only my curiosity, but also something that everybody knows. And we all know that in many neighborhoods of New York City, rent prices have increased a lot, and affordable housing supply has not kept up with the demand. Supply and demand problem has always been a thing. And many people spend a large share of their income on the rent, and this we know for sure. When I started to be very interested in this topic, I understood that I really need a deep research of this topic. That's why I read some articles and made some findings. For example, wages did not increase as fast as housing prices and the rent. And this is where we understood that it's not only like the social problem, but also the economical one. And after the 2008 financial crisis, constructions of new housing slowed down. And this is also when we can say that supply and demand problem increased a lot. This created a long-term imbalance between housing supply and the demand. And we also can tell that zoning laws in some neighborhoods limit how many homes can be built. And this is also often question about who owns the land and who owns the air about that land. And it very often don't really allows people to build houses that are bigger than for one family or for two family, and it doesn't allow us to locate many people in a one house on one area. And this is also where we can see that large investment firms began buying many homes and air and renting them for the profit. And this is problem when investment firms look at the housing area not as like a place for people to live in, but as a business and a thing to make money from. And as all crises that we have in our world, we know that it always highlights the problem that we already have. And COVID-19 is really one of those things which don't really create any new issues, but just highlighted the old ones that we had. And housing become much more competitive and rent prices increased because of all of these reasons. Here are my methods that I use to create my research. I use data from US Census, specifically from 2010 and 2022 years. I organized and analyzed data using Python and Census API. My variables was median income, median rent, and rent burden. I understood that those three variables will really help me understand and find the answer to my question. And that's why I created three maps for those three variables. My project is three interactive maps that I created using Python. I used Open Data for it, and it showed us like on those three maps, we will see on one of them median gross rent change, on the second change in income, and on the third we will see change in rent burden. And now I will show all the maps. Since they're interactive, I will be able to show them to you like that. As we can see, we see a very nice map with a lot of colors, and now we can go deeper into what those colors means. When we can see like very red areas, and we can see that it is the rent change. This number is not an actual price of the houses in those areas, it's just a change that happened from 2010 till 2022. And when it's more red, we can see that, for example, in this area, it is $2,139. And maybe in other areas that is less red, it's gonna be a little bit smaller, for example, $200. We can tell that there are some green areas. There are not much of them because it's New York City, but we still have some of them. For example, it means that the rent actually went down on $200. And this is the map for my rent change. It's one of those 3 maps that I created using Python code that we can see right here. The second map would be for the income change. And we can also see that in all of those areas that are red, the income really raised. We can see a huge numbers that people started to gain much more money, but then we don't really understand the housing crisis problem because we don't understand that even if the income raised so high, the rent actually raised much more higher. The percentage of income and the rent are very different. And here is where I understood that I really need to research more into the rent burden. And this is why I have this map created. We can see a lot of yellow area, a lot of orange area, and even if it's not really red, it still means that the rent burden really increased in most of the area in New York City. And we can now understand that even when the income raised very high, the rent raised even higher, and we can still have a big increase in the rent burden change. Here are those 3 maps. And now we can go into the results section. The results in our change in rent map, we understood that most New York City census tracts had a big increase in rent. Only few areas have seen small decrease in price for the rent. An overall pattern shows that rent prices are increasing a lot. When we looked at the change in income map, we saw that income really increased, but when we started analyzing rent burden, we understood that it raised not as quickly as the rent did. And when we look at that rent burden map, we understood that rent burden increased in most of the neighborhoods, and households are spending a larger share of their income specifically on the rent. My conclusion was that open data really allows you to research a lot of topics that you're interested in. For example, in my case, it was housing crisis in New York City, and it allowed me to do a study that looked at changes in rent in New York City from 2010 till 2022 and compared it to the income and the change in the burden. I was really happy to be able to look at the large data and visualize it in more understandable to me maps, and really got answers for the questions that I had. And this project could help not only people who are interested in housing crisis and just for themselves, but also for policymakers or those who can really have impact on zoning laws and really have a great change and make our society and our problem much more smaller. I would like to thank you, Professor Koringa, for help and supporting during this project. I also want to thank Professor Hart for his help and feedback. I want to thank Maths and Mixing Lab at Adelphi University for giving me tools and resources to work with open data. And thanks to my school, Rachel Carson High School, for supporting this research. The support that was provided to me was a huge part, an essential part in this research, and it would never exist without all the help and support that I received during this beautiful year. Thank you, everybody. Here are the references for my research. And here is my thank you to you all who listened.
Thank you so much, Sasha. Next is Wen.
Hi everyone, my name is Wen, and today I will be presenting my research on racial disparities in self-initiated police stops near New York City public high schools. So, first, to understand why this topic matters, we have to start with some context and background. So, research shows that 56% of youth experience some form of discrimination, but for non Hispanic Black male youth, that number jumps to over 64%. And moreover, studies have found that discrimination actually elevates cortisol levels in teenagers, which is the body's like primary stress hormone. And this could, when this cortisol level stays elevated over time, it can increase risk for heart disease, high blood pressure, and strokes later on in life. And more importantly, schools are supposed to be a place where young people can grow, learn, and feel safe. But for Black adolescents, the environment around their school can add stress rather than relieving it. And a big part of this comes down to policing. Next slide. Existing research tells us that in New York City, Black and Latinx individuals account for over 80% of all police stops, while white individuals account for only 5 to 6%, despite making up a substantially larger share of the population. And nationally, Black drivers are searched or arrested at more than double the rate of any other racial group. More importantly, research out of California found that searches of Black individuals are actually less likely to turn up contraband than searches of white individuals. And what this tells us is that the higher stop rates aren't explained by the rates of crime, but by personal bias of police officers. My study focuses specifically on self-initiated stops, which are encounters that officers start entirely on their own without prior calls for service. So no one called 911 for them, meaning that there's a high possibility for racial bias. And research from the Center of Constitutional Rights actually found that 1 in 4 of these stops lack any legal justification, meaning that they're unconstitutional. And Black and Hispanic individuals make up 97% of all self-initiated stops in New York City. This brings me to my research question. How does the proportion of adolescents subjected to self-initiated police stops within 700 feet of New York City public high school differ between predominantly Black and predominantly white schools? To answer this, I work with 3 publicly available datasets. The first dataset is from the New York City Police Department. It contains stop, question, and price data, which gave me records of each police stop in New York City, including whether it was self-initiated, the age of the person stopped, and the exact coordinates of where it happened. The dataset was filtered to only include self-initiated stops involving adolescents between the ages of 10 and 19. The 2 other datasets are both from New York City Open Data. The first one is the New York City School Demographic Snapshot from 2020 to 2021 school year. It gave me the racial enrollment data for every public high school. This dataset was used to classify schools as predominantly Black or predominantly white based on the student enrollment percentages. And the threshold I use for this study is 40%. So usually the threshold would be 50%. However, New York City is special because the public school population is extremely diverse. Data shows that white students only comprises of approximately 5% of the city's public school population, meaning a school with 40% white enrollment already represents a significant overconcentration relative to the citywide average. Finally, the New York City public school point location shapefile just gave me the geographic coordinates of every school so I could map them on the map. From there, my analysis had a few key steps. First, I generated a 700-foot buffer zone around each classified school. And what a buffer zone is, it's basically drawing a circle around each school to represent the immediate surrounding area. It's also worth noting that some New York City public high schools share the same building, so they have the same geographic coordinates. However, after filtering all the data for predominantly Black and predominantly white schools, there were no 2 schools of differing classification that share the same building location. Next, I did a spatial join, meaning I identified every self-initiated stops that fell inside one of those area and assigned them to a corresponding school zone category. From there, I calculated the total number of stops near every school, as well as stops per school to account for the fact that there were much more predominantly Black schools than predominantly white schools in the dataset. So luckily, even though I cannot pull up the live map, I have a picture of a map here because I anticipated this. But what we could see here is that we could see in the legend, I think, that the red dots represent predominantly Black schools and the blue dots represent predominantly white schools. And the black dots represent all the self-initiated police stops within the circles. As we can see here, in Upper Manhattan, that's where Harlem is. A lot of these stops cluster heavily in Harlem, the Bronx, and Central and North Brooklyn. And these are also the areas where predominantly Black schools are concentrated, and they are historically Black neighborhoods with long histories of intensive policing. And so now, when we're looking at Staten Island at the bottom there, and Lower Manhattan and some parts of Queens, there's not many black dots near them. And what this essentially means is that the majority of police stops are near majority Black schools rather than majority white schools. Also, for Staten Island specifically, I think it's worth noting that even though there are 5 predominantly white schools and around 2 predominantly Black schools, none of the dots fall near the predominantly white schools, and there are 2 stops that happen in 1 predominantly Black schools. So I think that's worth noting. So this is a data chart, and this chart compares the number of high schools to the number of self-initiated police stops for each group. The red bars basically represent the predominantly Black schools with 183 schools and 297 stops nearby. The blue bars represent predominantly white schools with 26 schools and only 6 stops nearby. What makes this chart important is that even though there are 7 times more predominantly Black schools than predominantly white schools, the stops do not scale proportionally. There are nearly 50 times more stops near predominantly Black schools. So even when you account for the difference in school count, the disparity is still overwhelming. So I have these 2 charts that break down the disparity even further. On the left, we could see that 98% of all classified stops occurred near predominantly Black schools, with only 2% near predominantly white schools. On the right, when we average it out per school, predominantly Black schools had 1.62 stops each, while predominantly white schools only had 0.23 stops each. That is nearly a 7-to-1 ratio. So we know from existing research that Black individuals are stopped disproportionately across New York City. And what this study adds is that the same thing is happening right now outside of schools, and the racial makeup of a school's neighborhood shapes how discretionary policing happens in that vicinity. Future research should examine multiple years of stop data to determine whether these disparities have shifted over time in response to policy changes. Researchers should also directly link school zone stop to measurable academic outcomes like attendance, GPA, and graduation rates, connecting policing patterns documented here to the students inside of those school zones. Thank you for listening. I'm happy to take any questions later on.
Thank you so much, Wen. Our final presenter is Gabby.
Hi guys, today I'm going to be presenting my science research project called Restaurant Inspections, Cuisine and Compliance. And my name is Gabrielle DeTerrafil, and I worked on this with Miriam Khan, which is my partner, and she could not make it today. Me and her, we were interested in doing a project that discussed inequality and discrimination, as well as consumer safety. So we came across this data set, which I'll talk a little bit about later, which inspired our project. So basically, our main research question is, in New York City, what factors actually affect whether a restaurant gets an A grade? And we specifically looked at some independent variables like the type of cuisine, for example, Italian, Indian, Japanese, etc., the neighborhood's income level, and whether the restaurant is part of a chain or independently owned. And we wanted to see how those factors matter even after considering instruction to violations. For our data, we use the official NYC Department of Health restaurant inspection data set from, of course, NYC Open Data. And it might be a little bit difficult to see, but it just took a screenshot of the data, like the first part. And this data set includes many different important things that we need to know. And the most important things, obviously, other than their name and location, are like real inspection results. They have the grades posted and specific violations describing like what happened, for example, rats, and other details for restaurants across the city. So everything that we're showing here is actual data, and we're not estimating anything. This is part of our background rationale, which explains like more about why the topic is relevant in the grand scheme of things. So restaurant letter grades like A, B, C are publicly posted to improve food safety and give customers more transparency. We did a little bit of research, and research shows that when these grades are visible, it can actually influence how restaurants behave and how customers make decisions. But at the same time, the restaurants depend on things like how inspections are done, how consistent they are, and even the neighborhood the restaurant's in. Because of that, understanding what affects a restaurant's chances of getting a high hygiene rating is really important. It helps us identify possible inequalities in the system and helps keep consumers safe. And also, I want to clarify that we're not trying to discriminate against any restaurants or cuisines. We just want to point out some patterns and see if things are statistically significant. And this could actually help the Department of Health provide better support for the restaurants so that they can stay safe and stay open. And I'll talk a little bit more about a possible solution, like free sanitation training. And then to continue the explanation, this topic's important because it affects both businesses and customers. The customers want to consume safe food and the restaurants want to stay open. And from our research, we noticed that A grades aren't distributed across NYC, which made us question if the system is completely fair or objective. We're not trying to target or blame any restaurants. The goal is just simply to identify patterns that might point to bigger issues like lack of resources or unequal standards. If we understand those patterns, the city could actually help restaurants improve instead of just penalizing them. So to give some context to the data set and also just the system in general, NYC uses a point system where fewer violation points means a better grade, and an A is between 0 and 13 points. There's also something called a possible Western bias, where health codes might be based more on Western cooking styles, obviously since we're in America, and not fully account for some traditional methods from other cultures. And another big idea that we looked at is whether wealthier neighborhoods actually have cleaner restaurants or if they just have more resources to meet the requirements. So our data set included over 1,700 restaurant inspections across NYC, and we focused on a few key variables like cuisine type, so Chinese, Indian, Italian, Mexican, Japanese, American, neighborhood income levels based on zip codes, and how often a restaurant gets inspected. We also visualized the data with a map where you can see that there's green dots and red dots. So the green dots represent A grades and the red dots represent B or C grades. So this is our map. And then this is some of the code that we did, right? And then, so a little analysis of the code is that our regression model showed that Chinese and Indian restaurants have statistically significant lower chance of receiving an A grade. The p-value was less than 0.01, which in statistical terms, this is very low, and it means that it's very unlikely, almost like close to impossible of this happening by chance. So it would take it into account, even when those restaurants were in wealthier areas, they were still less likely to get an A compared to something like an American restaurant. And we also found that if a restaurant is inspected more likely, the less likely it is to get an A. So once the restaurant gets flagged, it stays on the city's radar and it has a harder time of recovering and getting a higher score. So then this could raise like a future question. Does getting a B grade actually mean the food is less safe? Or does it just mean that the restaurant doesn't meet some of the technical document requirements? Because these are different things and people should understand like fully transparently from both the perspective of the city and the Department of Health and actually the restaurants themselves. And for future research, we want to look into if chain restaurants have an advantage because we have support from corporate, whether independent restaurants might have the same resources, like such as also compliance teams. And the thing I was talking about earlier, a possible solution is that the city could offer training, which helps immigrant restaurant owners and just generally independent restaurants get more resources so they can stay open. Because we want to focus on helping the restaurant succeed, not punishing them. And thank you so much for listening.
Thank you, Gabby. And thank you all for listening to all of our presentations. I'm going to open it up to questions and answers. I appreciate that you all were here to listen to the pilot studies that these students did. This is their first time working with open data and making these maps, and it's just really exciting.
Yeah. Thank you to all of our students for your great work today. Nice job. We'll also take any questions about the map club too. So feel free to ask us anything.
We also welcome questions from our presenters to one another.
I'd love to kick it off. Phenomenal job. I was so impressed by all of the projects. I was reflecting on when I was in high school or when I was younger, and I was not where you all are at. So I think you're incredible and keep doing this great work. My question is in your research, what's something that really surprised you or you had to challenge maybe your hypothesis when you hit that road or you hit that bump in the road?
I think for me, it was mostly because most of the time, when you do research projects throughout high school, middle school, you pretty much either A, know the answer, or B, you're going to get the hypothesis right. So doing my first large scale research project and not getting the hypothesis approved by the statistical correlation was it wasn't really a shock, but it was something new to deal with and grow from.
Yeah. Hey, Zach, I wanted to congratulate you on presenting that. There's even a lot of professional researchers like us, they never present it when they don't prove their thesis.
Yeah.
So they just bury that data and then wait for something else. Sasha, you wanted to comment on that too?
Yeah, actually, I agree with Zach. And when I created the second map which showed the income, I saw the income was so high. It was so much higher than the rent raise. And I was like, maybe I'm wrong. Maybe the rent change wasn't that high. And that was exactly why I created the third map and digged more deeper into that data to prove that my hypothesis is actually correct. And yeah, I was surprised that I faced such kind of the issue. It was very interesting to research.
Personally, I feel like my research was pretty smooth, thankfully. But something surprising was I did not realize that there was that much predominantly black schools compared to predominantly white schools. And also did not know that there were that many schools in New York City.
So Zach, after studying all these pools in New York, do you have a favorite pool, or is there a pool that you learned about that you want to check out?
Oh, my favorite pool probably is going to be the YMCA pool that I use for my weekly training, regardless. Holds a special place in my heart.
All right.
When you were looking at the schools, did you notice anything in particular about your school, or was there nothing to say about it?
I think my school is pretty boring. It didn't show up on the map.
So it's neither predominantly white nor predominantly black?
Yeah, I think we were pretty balanced out.
Sorry, just to interrupt. I checked the statistics actually. The actual numbers were 40% Asian, 20% black, 20% white, 13% Latino, and 7% other.
That prompts an interesting question for future research, which is whether or not there should be a third kind of school, predominantly Asian, since that would meet your criteria of 40% by your definition.
Actually, next year I'm doing senior research. I think I'm going to combine white enrollment with Asian enrollment because I found this study that in Stuyvesant is 90% white and Asian. So that's pretty interesting.
Well, let me just answer Vincent. Vincent, the club is actually open to anybody. So initially we were targeting undergrad students, but it's always been open generally. I think for the rest of the semester, what we're going to do is actually host a couple of lectures that are coming up. So we're going to have some people present on their projects around spatial justice, and we're going to hold a little seminar in a couple weeks. Just email Nicole. There you go. I was going to ask Sash, why you think the rent went down in those areas in a 10-year span? That's almost unheard of.
That's really interesting question. There may be many answers for that. Maybe the data is not accurate because honestly, I can't believe that somewhere in New York City, the rent went down. Maybe the crime is very high. Maybe just overall amount of houses is not that big. And compared to other neighborhoods, you can't really compare.
Right.
Yeah, I think to really answer that question, you have to analyze the whole data of that neighborhood.
It's true. If it's a very small sample set, then it might be affected. I think maybe if a large affordable housing project opened up, so if many new units came in the area, we could see if that actually affects it. If we pulled in some other census tables to look at the total number of households, maybe we'd get some insight into that.
Yeah.
So you have more work to do.
Thank you. Yeah, I definitely do.
I think that brings us to time.
It unfortunately does. But if you want to stay in touch, we have Nicole's email in the chat. Hope you all enjoy the rest of your Open Data Week. And thank you so much again to the presenters and attendees that came out today.